Thanks. Hey everybody, thanks for coming. Okay, so I'm the product owner for Infrastructure as Code at Barclays, and today I'm going to be taking you through how Barclays is automating their way to a more flexible future through the adoption of continuous deployment. I'm going to take you through some of the drivers for change, the tools that we've developed within that space, and some of the lessons that we've learned along the way. So, who are we? Barclays is one of the UK's largest banks with 325 years of history. We employ over 120,000 people in 40 countries. We have currently 15,000 developers all operating in an agile manner. We have 80,000 servers across 3,000 applications, and currently 500 of those applications are sitting within our hybrid cloud. Now, if I was to say to you, what did Barclays do, or what does a financial services organisation do, you'd probably say something like move, lend, send, or receive money. You probably wouldn't say develop software. And we've only really started thinking of ourselves as a software house for probably the last 2 to 3 years. But if you look at the snapshot of history, some of our key activities for the last 60 years on screen, even if we go back all the way to 1966 with the UK's first credit card, can you imagine the amount of software that it took to reconcile all those transactions so you could use it in a supermarket checkout? Or the world's first cash machine. That would have had a UI to it. It might have been basic, but it would have had a UI that you could have interacted with. And then, if we fast forward that to 2007, with the where really our industry went through a fundamental change as we moved to a more online, digital, and mobile presence. And that coincided with the release of the first smartphone back in 2007. And that saw us competing in a space where more mobile and more nimble and agile development teams operated, such as the marketplaces for Android and Apple. And that saw us competing for our value-added services. There is a directive currently on us, which is the PSD2 directive, that is going to see us open up our data via API for them third-party vendors. So that puts us even more into competition with these small market development teams. If they want to, for instance, if you want them to crunch your bank account history to see where you've been shopping, how you've been spending your money, they're all stuff that we add on top of your current account today that we're going to have to compete for. So if we're going to have to compete in that space, we've got to get more nimble and agile ourselves. So we recognise we need to change. But Barclays operates in a very regulated industry, right? So according to Wiki, there's 243 regulating bodies over 139 countries. And I've pulled out some of the big ones on screen there that have an impact on us in infrastructure and applications. So for instance, the FCA, the PRA in the UK, or the Fed in the US, or MAS in Singapore. And each one of these has very tight regulation around the installation and operation of IT services. And to make sure that we're meeting that regulation and reducing risk for the organisation, we see a lot of manual process that creeps in over time, and that stops us competing with them smart market developers. So what stands in the way of us creating awesome content for our customers? Well, at Barclays, the infrastructure and developer were very disconnected. It could take weeks, like 6 to 8 weeks to get a physical or virtual server, right? And even when you get it, you might not have access to it. You might need to use configuration management tools or whatever that looks like, or actually run colleagues. The solutions had to conform to really tight patterns. And believe it or not, we did that to speed up our delivery to production. But what that stops us doing is innovating. If you want to do something new, then you end up on the edge cases of that whole overall pattern, and then you can be tied up in manual process, getting authorization from security and so on for it. And then finally, in order to get that physical or virtual server, you need lots of teams involved. It could be the storage team, the build team, the application team, and all of them teams have SLAs associated with them that again slow us down. So Barclays has been on a DevOps and Lean transition now for the last 3 years, and it's led to some of the following improvements. All of our code is now stored in VCS repositories, so we can say who did what, where, when, and what potentially the downstream impact of that is. We've introduced a hybrid cloud, and that allows us to not only take advantage of the flexibility of the cloud APIs, but it also removes a lot of the capacity concerns that we used to have with the old estates. We can now make use of the extended capacity of the cloud providers. We've introduced a sandpit area. Now, in order to reduce that risk to the bank and make sure we're adhering to that regulation, we don't really give out administrative rights to our laptops or desktops or servers. So where does a developer play with software? How do they know whether they have to build something rather than, whether just buy something or potentially just use a plugin off the web? So we've created a sandpit area that's ring-fenced off from our core network so that developers can download stuff, have a play with it. If they like it, then they go through the process to get it into the bank. We've introduced DevOps tooling. We're a large chef shop, and this solution I'm going to show you is largely built around that and Terraform to make best use of our licensing. We've also introduced centralized Jenkins, we've got the VCS repository, basically anything you need to build out CI/CD pipelines. And then we've gone about educating our teams on how to build those pipelines, do unit testing, do integration testing, and so on. We've also worked very hard to reduce the blame culture between dev and ops. So the operation teams have been having a lot of training around code-based activities to help them understand things like Terraform templates or the actual code that the application teams are writing, so that they can understand when they're pushing a change to production exactly what it is that they're actually doing, and then they can wind it back if they need to. And then finally, we've got developers teaching developers. We've got a lot of community of practices across Barclays where developers demo to each other what they're actually working on, and that leads to a lot of reuse of code as well. If one developer happens to like what they're seeing, they'll pick up the phone and we see it transition into that app. Now, it's not a perfect world, and we've still got some challenges that exist, as you'll see when I walk through the solution, but one of the key ones is we have a pause just before production now, and that's where we do our pen testing and our compliance reviews. Now, we're looking to automate that with tools like Inspec and Metasploit, but we're not quite there yet. We're actively working on these. And then we want to get to the point where we do automatic rollback. We don't want to be in a position of forward fixing all the time. We want to be in a position where we just roll back to a good known common base. So the transformation plan, the introduction of the hybrid cloud, it came with a lot of flexibility, but it also came with a lot of challenges as well. The APIs are so flexible that we saw all of our developers, or a large portion of them, using them in different ways. And that just doesn't scale. When you've got 15,000 developers and 3,000 app teams, you can imagine having to rebase people's code because something's not working correctly. Even 10% of them could almost take up a full day for a support team. So we had to do something about it. And the CTO function that I'm part of and the IAC team that I'm responsible for were tasked with coming up with a common method of deploying application infrastructure change to that hybrid cloud and then selling it to our developers. So that was based around 3 solutions. The first one is test, and that's give our developers a centralized way of testing that application infrastructure code so that they can build these immutable test environments, they can perform integration testing against it, and they're stripped down afterwards so we've got no technical debt associated with testing. The next one is promotion. Give our developers a common way of promoting that application infrastructure change where the infrastructure, security and compliance teams can do scraping for malicious activity in a set of pipelines rather than doing manual process, so can remove that manual process from the pipelines. And then lastly, deploy, so give them a common way of deploying to the hybrid cloud. So that led to the continuous deployment toolkit, which is made up of there's a solution for each one of these principles, so test, promote and deploy. So before I can do that, I need to take you through how we do Chef at the bank, because this is how we create our immutable application configuration. So when you're creating these promotion pipelines, it's very, very difficult to do pattern matching on stuff if everybody's using it in a non-common fashion. So the first thing I did was I set about creating a set of building blocks and a set of patterns around usage of Chef, and then wrapped an education piece around it to teach people how to use Chef at Barclays. The first one is the library repo, and that is, think of that as the building blocks. So that is your architectural building blocks. It's typically supported by an infrastructure or a middleware team. It contains a library cookbook, and the library cookbook is the only thing that's stored inside our Chef supermarket. It has nice readmes around it that show all the inputs and how developers should use it. And then we've got the application repo, and that contains everything that the application team needs to build out their application in production. It's contained in one place, it's promoted as one, and that contains 3 cookbooks. So the wrapper cookbook is for overriding attributes inside a library. So think of Apache and maybe making Apache listen on port 81 instead of port 80. The application cookbook is what it says on the tin, that is the application teams use it to install the application. And then the role cookbook really is about wrapping all of those together to create this immutable stack. And each one of these comes with a version in its metadata file. And what the role cookbook's really saying is, I want version 1.1 of the application, 1.1 of the wrapper, and 1.1 of the library. So if we were to version this out now, in fact, that's the dependency structure. So the role cookbook depends on the application on the wrapper on the library, right? So if we were to version this out, because the middleware team have just come out with the new Apache cookbook, we would version out the entire stack because the bottom piece has changed and the dependency order all sits like that. But if we were to just turn a red button to a blue button inside the application, and we were pulling some new files down from Nexus, we'd just do from the application upwards. And that's how we're creating that full, consistent application stack for the developer. Now, inside an application repo for a typical 3-tier architecture, I'd expect to see 3 role cookbooks with a multitude of applications and wrappers inside it. And each one of them would have a version associated with it. And that's what we call the app stack. That's everything you need to stand up your application. Okay, so the first solution is test, and that's libvirt test kitchen. Now, at Barclays, as I said, we don't give developers administrative access or root access to the laptops. So it means that they can't install a Chef DK and then potentially a hypervisor such as VirtualBox. So instead, we've built out a solution in our data centers that's highly available, production supported, and so on. And that consists of Jenkins wrapping the Chef DK, and then a couple of hypervisors with an API on the front end so that developers can interact with it programmatically. Developers would be working on an application repo at this stage. Now, they create this application repo from a front-end portal called the repository management portal, and that allows them to create like inspect repositories, library cookbook repositories, application repositories. And if they create the application repository, it uses a code generator to flesh out the structure of the cookbook underneath it. So they get the structure for the role cookbook, the application cookbook, and so on. So they don't have to worry about their kitchen.yaml files and all that good stuff that comes with it. All them complexities are taken care of. The application developer can focus on sticking his code inside his role cookbooks. So they're working against a branch. They've got to the point where they're happy with the code base, and they would call out the script that supply 2 parameters. First one is the set of credentials, so we know who's standing up the instances, and we can track it in the logs. And then secondly is the branch that they're actually working off, so we know what they want to test. And that executes against the API, and it creates that 3-tier stack for them, so they can perform some integration testing against it. And it'll give them an output in a near-native format that says whether the cookbook converged correctly or whether they have to look at it. If they have to look at it, they can look back at the instance, log on to them, find out what the problem is, update their branch, commit the code, and then run a reconverge the exact same way they would if it was on their local desktop. So now we move into the promote phase, and this is the set of pipelines that protects our cookbook promotion. This is what does all the scraping for malicious activity and so on. So the application team is working against the repo, they're happy with the code, and they want to merge it into the master, so they do a pull request against it. We've got 2 pairs of eyes on every piece of code at Barclays. So somebody approves it and the merge happens. There's a webhook that's on that master branch. So the first phase of the pipeline is audit, and inside that there's 2 phases. First phase is food critic, and that's I class that as malicious activity monitoring. It's checking to see whether anybody is manipulating something they shouldn't do. There's about 40 controls inside that currently. And then the second piece of it is Rubocop, so that's lint checking to make sure that your syntax is correct. If you fail any one of them for any reason, the pipeline will exit, your code doesn't get onto the Chef server. The next one is compliance. Now, this is really exciting for us because this has the potential to reduce all that manual process associated with audit each year. All the spreadsheets and PDF documents you all create, right? So this is using InSpec, and what we've done is we've built an API in there. Because the role cookbook and the application repo is the thing going through the pipelines, each one of them library cookbooks down there has a profile, an InSpec profile associated with it, so it's the controls. Think the controls around Apache, and there's about 58 of those controls currently inside the Apache cookbook. What the pipeline will do is, if the application repo is going through the pipeline at that time, and the developer hasn't included tests for the library cookbook inside his tests for his role cookbook, the pipeline will exit and tell it that they have to go back and include this specific set of tests, the ones that are in their dependency stack. So assuming that's the case, the developer then changes that, resubmits it to the pipeline, and the 58 controls are all assessed. If they fail any one of them for whatever reason, then the pipeline will exit again. And what we're trying to do there is drag that failure as close to the developer as possible. What typically used to happen was developers don't read security standards. So we get to the point where we've got the UAT, and that's where we have our pen test and so on. And then the developer gets told they've breached some standards, so they have to go back, rebase the code, resubmit it through. They missed the pen test window. It costs Barclays money. So bringing that failure as close as we can to the development stage means that we avoid all of that unnecessary extra cost. So then, assuming that all passed, we go to the upload phase, and that sticks the cookbook structure on the chef server. And there's some security that just makes sure that can't be put into play until the application teams call out for it. And then we move on to the promote phase. And what that's going to do is, it basically says, I want this version of the cookbook, web in this case, pinned in dev1, and you can see that's gone in there. And that's how we create that mutable stack. Any instance that's spun up, we put it in a particular chef environment. And because the version of the cookbook is pinned inside the environments file for chef, it means that the server gets that version of the cookbook, and the application teams can promote that whenever they're ready. So they could have a new version of the cookbook all ready to go, and then they just call out when they're actually ready to actually put that code into play. So the last piece of it is Terraform, and this is really what brings that application and infrastructure configuration together for us. It's based on Terraform open source at the moment, and we're working to migrate this to Terraform Enterprise. It's currently in the lab, and we're actively working. We're hoping to have that completed by the end of the year. We're just waiting on some of the stuff for the PTFE instance that's coming in maybe a month or two's time. So the application team would be working against their Terraform repository that they've created at the front end. And for the open source version, what we've done is we've wrapped the binary inside Jenkins so we can do some orchestration. We've got console as a remote backend, and then we've strapped an API onto the front end of it so that developers can use this within CI/CD pipelines. So the development team are working against their Terraform repository. They've potentially pulled in some modules from our module supermarket, which is the module registry you saw called out at the keynote yesterday. And then they execute it against the API. And what they do when they execute is they supply 4 parameters. The first one is the AWS credentials, which for us, we use the STS service from Amazon. So the session token, the combination of that, the access keys, secret keys, will dictate which account you actually go into, non-prod or prod. We also supply the repository, so we know what repository your role cookbooks are actually contained within. And then we've got the 2 runtime environment variables, which is the chef environment, which in this case would be dev1, and then we've got the role cookbook, which would be web. And we actually use the bootstrapping process of the instance to say to the chef server which environment it's going to go into and which role cookbook is actually going to go onto the server. And we use user data to manipulate this process so that we can feed it in at instantiation time. So that then results in, no surprise, the application stack that we were looking at before. So we end up with a web, an app, and a data, and they're at the versions as described inside the app stack because we've put it inside dev1, and inside the user data we've described, what cookbooks we're going to go on what instances. So how do the application teams use this in their CI/CD pipelines? This is a bunch of APIs that they call out to. They would be responsible for creating their own CI/CD processes around that, right? So the first thing they do is they create the templates or configurations. They make sure that they're either merged into the master branch or that they've been through the pipelines and they're up on the chef server. In this case, we've got 1 cookbook, 1 role cookbook, web, and it's version 1.1. So now over to the application pipelines. The first thing they'll do when they kick it off is the process calls out to that promote API that you saw before, and it will say, I want web 1.1 pinned into test 1. And then they call out and they create the infrastructure, and they pass the AWS credentials, the repo for the Terraform configuration, and then the 2 runtime variables that we wanted, which is we wanted to go into test 1, and we want the role cookbook to be web on these instances. And we get 2 instances combined with an auto-scaling group, because we've used the launch configuration in the auto-scaling group to actually pass through that role cookbook and the environment data to the bootstrapping process. And then the application teams would perform some integration testing against it. And this could be anything, right? We normally typically see at the test phase some very basic tests like just pinging a website, and then they'll get more and more stringent as they go through to UAT. So at UAT we might see a point where we break out into app dynamics, we start doing some real-time performance testing against the app, and then the feedback of that will trigger the pipeline again. So after that, we call out and we destroy the infrastructure. So we've created that immutable infrastructure stack, we perform the integration test against it, and then we destroyed it afterwards, right? Then we go again. We tend to do this 3 times. Now, depending on what your category of tier is, so if you're a Cat 0, you might see more tests than this. There might actually be like 5 stages of non-production testing. It depends what it is that we're actually doing and what the application actually influences. So let's assume we've got 3. So we do the integration testing again, and as I said, each time this gets more and more stringent, and just before production, when we're raising the change control, we'll package all of this up, and then we'll put that as evidence for the test closure report. So we destroy the infrastructure again, and then we go again in UAT. And each time you can see that we're promoting the role cookbook into a different environment, and we would be changing the environmental variable that is associated with those instances. So each test, it would have been going into test 1, and dev 1, and then UAT 1. And then we get to production. This is where we have our manual review. This is our manual change control at the moment. And then somebody would go and kick off that pipeline. Now, it will probably always be separated into 2 teams, because we have a developer access to production rule in regulation, which means that a developer can't build a back end into a particular product and then push it out on their own, right? Because that'd be really bad. So we kick off the promotion, only this time what we do is, when we call out, we say prod 1, but we change the AWS credentials in it. So now it's pointing to our production AWS account. And then we perform the integration test. Now you'll notice that there's no destroy infrastructure on the end of this part of the pipeline. And that's because we use the declarative nature of Terraform to change the end state in production rather than stripping it back down so we can do non-disruptive change. So what would this look like if we were doing blue-green? What you just saw there was us right into AWS for the first time, basically. Right? So if we're going for a blue-green deployment and we want to do non-disruptive change. So we've changed the application cookbook, we're changing a blue button to a red button on the website. And we've updated the role cookbook because the application cookbook has changed. It's pulling down new files now from Nexus. So we call out, we start the pipeline, and we get that promotion process that we saw before, where it pins 1.2 into test, dev, UAT. We would be creating all of the infrastructure inside our non-production accounts now and doing the application testing and infrastructure integration testing across it. And if it fails for whatever reason at any of these points, obviously the pipeline fails as well. And then we get to production. Now, the difference here is, you can see that the infrastructure is already running in prod 1.1 because we've not stripped it down, right? When we call out to this configuration that we've done this time, we supply the runtime variables, we change it to prod 2. So the instances go into a separate chef environment. And that chef environment is going to have 1.2 inside it. So when the instances get spun up, they'll get version 1.2 of the code. So now we've got these instances with version 1.2 of the code, right? And on the auto-scaling group, we use some uniqueness on the end of the name. And what that did, it forces Terraform to recreate that auto-scaling group each time we run the configuration. So we also use 2 parameters, which is wait for ELB capacity and create before destroy. And that'll ensure that the auto-scaling group is all nicely warmed up and tested before we actually cut over to it. And then we'll cut over to the instances, destroy the auto-scaling group, and we're now running in production with version 1.2 of the code. So the module supermarket or module registry that was talked about at the keynote. Now, I call it the module supermarket internally, so we create those synergies with the chef supermarket. People already know there are building blocks for our applications. For us, it's going to be based on Bitbucket, and we're waiting for that integration to come in the PTFE installation within the next month or 2. Which will then see us go to production with this product. But we've already started building out all of our modules. Our AWS accounts are actually created and configured using an in-house written tool. And we did that because Terraform hadn't really reached critical mass by that point, at the point we went live with this. So now we've got access to the Terraform Enterprise licenses. That's probably something we'll change later. But we do use it for all of our application configuration items, so stuff like the auto-scaling group, launch configurations and so on. And we've actually created, as part of the acceptance criteria for stories for actually creating some of these technologies, the module is an output based on one of them. They're centrally supported by the infrastructure as code team at the moment. It will be the infrastructure as code run team rather than the engineering team later on. Modules will be versioned. Now, in our internal one at the moment, before we get the module registry, they're not versioned. If we want to version them out, we just change the code inside them. Next run, everybody takes the change. We want to really get to a position where our application developers are choosing when to move to the latest version of the product, because we don't want to force change on them. It causes outages, right? You've probably seen from the keynote that there was that versioning box on the module registry. That means that we can make use of that item when it comes in. And then finally, we're working with HashiConf to really work out a process of how we can build a community around this. How can we let people create modules of their own and then promote them into this module registry? And that's something we're going to be working on over the next few months. So why did we choose Terraform Enterprise? We had a great working version. It still works great today of the open source version. Number one for us is support. You've seen now that the Terraform is intrinsic to our delivery pipeline, right? And if you've got a category 0 application such as online retail banking, and you can't get change out to that, and we've got an outage, then we need somebody on the phone straight away. So we need support around this service. The API, we've been working with HashiConf to pass credentials in line. At the moment, most of the promotion actually happens based on a merge into the master branch inside the enterprise product. We want to be able to pass them credentials over an API, and you saw some of that come in at the keynote yesterday with the workspaces that was announced. Login, really, really important in a regulated industry, as it probably is for everybody that's sat here. We need to know who did what, when, and what did they do, right? And the integration with Bitbucket gives us that ability. We can say, what did you change inside the configuration, and who promoted that configuration? And depending on how long we want to keep that data, like a Cat 0 application might be 10 years, all the logs are kept in CloudWatch. We can scrape them off to Splunk, and then we can keep them for whatever the retention period is. The next one is a UI. We didn't have a UI for the open source version, and we've talked a lot about building these into the APIs and CI/CD pipelines, but we're not naive enough to think that nobody will want to use this thing manually, right? The UI updates that we've seen at the keynote yesterday are really important. You can see all of your information for a run team is literally stacked in one page now, and that's going to be really important for us as we go, we implement this in production. The next one is ACLs. Role-based access in a regulated organisation is paramount. And with the new workspace feature that was advertised, we're able to say now this particular team can do these particular operations against this workspace. And a workspace ties back to an AWS account for us. So now we've got that fine-grained control that we were looking for, that we were missing inside the open source version. And then next, the policy engine. This is really, really important for enforcing that control. And this is Sentinel that you saw announced. When you look at the Terraform pipelines, the reason we have all that control inside them pipelines is to make sure somebody's not doing something either malicious or it's just defective code. We want the same for our Terraform pipelines. So if I was to turn around to a regulator, for instance, and say we're implementing ELB as a technology, and if they use the module in the module registry, it'll make sure that we stand up to our regulation around resilience, which is it must go into at least 2 or 3 availability zones. Well, if we, the first thing they're going to say to me is, can somebody write a configuration that puts it into 1? And being honest, I'm going to say, yeah, of course they can. So this will stop them being able to do that. I can put a rule inside the Sentinel that says if you're using or promoting an ELB configuration, it has to be in 2 availability zones. Otherwise, they can't get that out to production. And it means I'm moving into that proactive state again, moving that change, that failure as close to the developer, rather than getting that remediation activity off the audit team, which will be go and scrape all the ELBs and tell me which ones are in 1 availability zone, and then do a remediation activity around it, right? It cuts down on waste. And then lastly, vendor-based rather than self-write. The open source community is great, but a lot of the features that we're interested in are pushed into the enterprise product because it's enterprise customers stacking that against their backlog. Well, we've already seen products that we want to, or features that we want to take advantage of, and they come from other organisations. We might not have seen them if it had been in the open source version alone. So what lessons have we learned along the way? The first one I would say is go all in, right? As I said before, we configure our accounts with an in-house written tool, and that causes us no end of pain because we have to get creative about how we pull that things like the VPC ID in when we're building an ELB, because it's not in that common state backend, right? If I was to do this again, I'd have a pipeline, something like Sentinel, or potentially, if you're using the open source version of Jenkins pipeline, that makes sure that all of the base modules, such as guardrails, IAM policies, the base configuration for network, all of that is included before you can merge it into the master branch or before you can get that actually into one of our workspaces. The next one is check your code. So we don't have any pipelines over Terraform at the moment. You've seen that from what I've displayed. We're going to use Sentinel to do this. So this will be the malicious activity monitoring or defective code monitoring that stops us needing to do all that remediation activity. Because otherwise, the service just won't scale. By the time you get 10 application teams all picking up the phone to you, saying that my code's getting this error back from AWS, and because it's a proxy layer almost on the front of it, we might get to a point where the developer doesn't get the true message back. They get a Terraform message instead of an AWS message, so they'll pick up the phone, and we waste time every time we do that. So if we can stop that behavior before it gets into an account, great. Use modules from day one. We went down the route originally of just letting developers do whatever they wanted inside the configurations, and that's going to end in disaster for us because there's just too many developers out there. With 15,000 developers, even 1%, as I said before, could potentially tie up, especially my team at the moment. I personally, when I first took over the team, was getting at least 10 calls a day for Chef before we put all these pipelines and building blocks and patterns around the usage of it. So I know what that can do to a team. So them modules are going to be your architectural building blocks for things. So that's what's going to give you consistency. That's what's going to allow you to reduce your burden on your support teams. The next one is reduce manual change. Inside our application pipelines today, or our accounts, we've allowed manual change to our AWS accounts. It was part of our strategy to give a native experience as possible. But that's potentially going to cause us problems downstream. It's not yet, but it probably will do. When we've got a Sev1 incident and all hell's breaking loose, there's a good potential for somebody to make a manual change in there, and then what happens when Terraform reruns? It's going to take it back out, right? And there's a potential that we're back to the Sev1 incident again. So again, that's probably something that we'll look at in 2018 as we learn more about this tool in SER. And then lastly, test your code. These application pipelines that you're building aren't necessarily just there for testing your application configuration. If they're making a change to, they're upscaling an auto-scaling group or something, they should be passing that configuration through the test dev UAT. And if you've got something like Sentinel where you can stop that promotion, or some of the new workspace features that are coming into Terraform Enterprise where you can potentially say that your code has to go through these particular workspaces first, then do it, because otherwise you're just going to get people promoting code straight to production, and again, that's going to end up in disaster. So I just want to pull you back before I finish to that first slide that I presented, where the infrastructure and the developer were disconnected, where developers waited months or weeks for servers, where their solutions needed to conform to these really tight patterns, and it stopped us being flexible and iterating change. And then the amount of support teams that were possibly involved inside a build out of these instances. So where we are today. So developers can exploit our cloud now to create competitive advantage. They can build solutions from their application and infrastructure configuration in minutes against our hybrid clouds. They can experiment, they can spin up immutable environments that have no technical debt associated with them, or they can play in these sandpit environments where there's no risk to the bank whatsoever. And that makes them a lot more agile in their development processes. And then finally, they can build repeatable solutions because they've got it all held in configuration now. We also see a lot of configuration sharing. So if an application team stands up a secondary application that has a very similar profile to it, because we're feeding in the chef cookbooks in line as we run these configurations, we get reusability in that code across our 3-tier infrastructures. And that's it. Thanks for listening. Hope you all enjoy.